Okay, today what we're going to do is we're going to talk about making these, just putting to set up an anti-static area for homemade anti-static bracelet and getting a ground for an anti-static mat. What we're going to use today is we're going to take a broken power supply, ATX broken power supply. The ATX could be a pure power supply. It could be, who knows, it could be a TV if you wanted to. Take the connector off of it, but be careful not to plug it in while you're on if you take it out of a TV, because the connector on it could have ends on it and it could make it where the current can flow to you, and that could cause some very big issues if you know what I mean. Anyway, what we're going to do is we're going to take out all the boards and the two varistors that are connected in series between line and ground and neutral ground on the connector. I cut them off there so we don't need them. So let's get going. First you'll need is one of these. It may not look like these, because the ones you probably get from Radio Shack will be brown or white colored with brown, black, and green stripes on it, and of course maybe a gold for 5% tolerance or so. Anyway, these resistors here, the 1.5 meg, you could use, what I recommend using is a 1 meg ohm resistor, since that's the lowest you should go on limiting current for anti-static discharge stuff, for protecting it, because they'll protect you and it'll also protect the device you handle. You see, if you call it static electricity on it, it may go through there and it may flow at highest current as it can, and it can harm stuff. But this here will limit the current a lot, and it will make it where it will not hardly any hurt the device at possible chance. So first thing you want to do is take one of these resistors. We'll twist it around with these air holes. Make a loop around these air holes on there for the fan that they put in here for air to go through. It's not needed, since there's nothing in there that's going to use air. Probably put it away from the outlet. You don't want it to be going against the outlet connector. And if you want, you could also get an outlet connector if you don't want to use up to two. What you call it? The two line in and line out wires. Anyway, when the tire twisted around there, it should look like this. As you can see, the resistors on there. If you can see that, I twisted around with two holes. Hold it in there. You want to solder it so it stays in place. And another thing is for your wire. When we talk about making an anti-static bracelet, we're going to use, where did I put it? Here it is. We're going to use as braided wire. If you don't have no braided wire around, take a broken USB cord that's shielded, or maybe HDMI will do as well. Since HDMI has to be shielded like so, it'll look like this on there for braid. We're going to strip the black stuff off of it, the black jacket off of it. And if it's too hard to strip without cutting it into pieces, cut it into pieces without. We're soldering them soldering them together to make one piece. Because how it's gonna go on your hand, it's gonna go like this. Put it around your arm, like this, and you twist the two ends together, like so. If I can. And it holds together like that. See? And that makes a good connection between there like that. And maybe if you have the cord still to it, then you can take the drain wire, which is the unshielded strand of one wire that they put in there, or maybe the braided wire. Put it up against the rest of the wires. This is USB, so it has brown, it has red, black, and green, white wires. Took all 4 of them. I'm going to twist them together like this. I'm going to turn my soldering iron on over here. And we'll solder that together so it makes a good connection between it. There's a drain wire right there. Take our drain wire. They call it a drain because it goes between the shield on these shielded cords. Or you just take the braid, twist it around it in case you don't have that drain wire. But most cords you'll have that. Actually on my cord, actually I don't think had it. For some reason. Maybe because the connector could make the shield when they crimped it on there, or soldered it, or what they did to it. All these blades should be solderable. Like you see, there's a little bit of gap there when I tried stripping it. It got the braid on it, but that's okay. We're going to use electric tape also to help with prevent scratching your skin and stuff like that. Because those solder joints will scratch your skin. Anyway, let's get going. Let's start soldering. Okay, got my side iron here. We're going to take our side iron and we're going to solder the 5 pairs actually. Because we got the unshielded wire. This white wire come off. Doesn't matter. We're going to have all pairs of wires there, so it makes it so that no matter which wire fails, it all will work. So we'll put some big gob of solder on it. The gob of solder will just hold the wires together so they don't come loose. Now you may not have that on there in case you just took it off with like a different HDMI to strip 2 pieces and cut it in half. Then you don't have those 2 wires and then solder to the braid. But I like soldering all the ones that are not part of the braid with it so that it can give it more continuity and less resistance. Even though it's not needed. And it's getting hot. Okay. Got that done. Now we're going to strip this in and put it to that resistor and put tape around it. Okay, now we're going to strip this in here with the scissors. Like so. And pull the black thing off of there. We'll cut the shield off since we don't want to touch the case, and then we got since the shield is already connected to this pair of wires, to these 4 pair of wires right there. It doesn't matter if it's gonna use those or not. We can just use them as we want. To use all 4 of them, so that has one make connection to the other one's world. You never know if the cord will fail. It'll have a short. It'll have a a short wire on it. I'm gonna take that little resistor that has nothing on it. Oh yeah, I gotta solder to that resistor too, and I forgot to do that. I'll do it right now. Actually, solder's actually sticking to the case of this one. I think. No, it doesn't. Thought it did. Anyway, it doesn't matter. We got the resistance series right there. With the case there, since the case does go to ground, since you see the green wire in that connector, and there it goes to the case, which is exactly what we want. Now for the cord. So we're going to do this cord I put between this wire stripper here. And we'll choose, I don't remember which one it goes in. Maybe we can do all of them at once. If we're lucky. And you got pull on it. Do it one at a time. Don't like what it did to that wire. Let's just take the other different gauge. I think that one is just two. Just one wire, two wires, three wires. Do the fourth one again. Four wires. Okay. Now that we got all four wires here stripped, we're going to solder them to the other end of that resistor. Twist them all on that lead. After that, we'll put duct to electric tape on it. Like so, like that. See, that's on there pretty good, I think. Now we'll put tape over it. Electric tape. more the electric tape. Now what we'll do is we'll tape this wire here down, this lead here down, so it doesn't come loose or break off. When I measure it, should come out to 1.5 mega ohms resistance. Between the ground pin and the braid. That should hold it down. Looks like this now. Now we gotta test to see if it actually is gonna work. To test that, we'll measure the resistance. With the highest resistance we get, or at least in the 2 mega ohms range, should do well. Or 2000 ohms, 2 kilo ohms, whatever your meter says for it. Okay, we're gonna measure from the bracelet to the case first to see if we get at least 1 meg, or if you're using 1.5 meg, which I'm using 1.5 meg. And so far, you can tell on the screen, we're getting 1.5 meg. It's measuring in 1,000 kilo ohms. Kilo ohms actually is measuring in. Now if we measure from the bracelet to the prong, the ground pin, with the same thing, so it'll work. And if you want, you can put a circuit in there that has LED and light the LED if you wanted to, between the ground and line. You could use the 2 other pins on that connector to do that, and put a small circuit board, a resistor, capacitor. You need a 220 nanofarad capacitor, 1 kilo ohm resistor. I don't know what wattage. I just saw it on the internet. It didn't say anything about wattage. You may need it to be half watt, maybe 1 watt or so. Who knows? It might not matter because the capacitor might limit the current enough that it doesn't matter what wattage. That's probably why they put a capacitor in it, since it's like a high power resistor. Anyway, it'll work. Now we're going to go over there and show you how to test the ground to see if it's going to work. Okay, to test the outlet for ground, you could use this tester here, or you could use an expensive one. This tester here is just for ground only. If the tester is for static electricity in ground, this is what we'll use, electrostatic discharge. Because it tests the ground for high resistance, for its resistance, its current source, how many current it can source out. Anyway, to test it, we just plug it in to the outlet. It's wired up to have line to ground between the outlets, line and ground between the outlet wires, the light bulb wires on it. and it lights the light bulb through that instead of line and neutral. It's modified. Carefully plug it in there, turn on. As you can see, oh boy, that's bright. If it lights up the brightest as it can, that means that there's a good ground there. Now if we we can do this one here. It's a GFCI outlet tester. Just plug this in over here like this. You can check the operation. As you can see, there's a green, only green lights light up on it, which means it's normal. Means that the ground is okay. Now, the house I was in before, the outlet in the garage didn't have a good ground. It was open actually, which is not good. They never changed it though, and I still think they didn't change it, which it should. Anyway, that's it for that. And there you go. Static electricity to prevent it from happening is usually has to do with your grounding. If you ground it where the pipes go down to the ground and metal wires go down into the earth's ground outside, and the dirt and stuff like that, it'll go far down enough. It'll prevent static electricity from breaking stuff when you connect yourself to it. And that's why it's a good idea to test these grounds on it, because it's not. If you're in a house that has like a where did I put it? I had it with me. I put it back in the room. That has 2-prong outlets. You get yourself a 3-prong outlet adapter. You can test it between there. But like I have hooked up right there right now, this thing. You plug this thing into here, and then take the screw from your outlet cover, put it between the tab right here. Make sure you do that. It will not work if you do it without it. Light bulb won't light, telling you the ground's not even there. See, if I do it like this, I take this here, plug it into like this, flip the switch, it doesn't light, as you see, because the ground's missing. And with this here, you get a red light, and that means bad ground. So that's why you have to do that. You can try and put it in there, and that's why it might be an idea to get this, so you know that you're safely grounded. You can build it yourself, or you can buy it from me. It's going to be less than what it'll take to build it. You gotta get a light bulb, you gotta get a high powered light bulb, 60 watts at least. And it cannot be, because it cannot be LED and it cannot be fluorescent. It has to be a standard incandescent light bulb. Otherwise what will happen is it will draw too low of current and it won't be able to test it correctly. So there you go. I hope you enjoyed this video. Hope you learned something. Thanks for watching. If you like it,